Hi everyone. In this video, we're going to cover section 3.4, composition of functions. First, let's start with our warm-up. Find the domain of square root of 2x plus 6. Keep in mind that square roots have restrictions. They need to be greater than or equal to 0. So let's go ahead and solve the inside of that root. We are going to get x is greater than or equal to -3. And written with our interval notation will be -3 to infinity. Okay. Domain of the next one, keep in mind it's a fraction, so this cannot equal 0, will be x plus 3, cannot equal 0. So our domain is -infinity, skipping over -3, picking back up after it to infinity. Then a little bit about our functions from last unit or last class. We're going to plug in -2 and simply solve. We're going to have 4 plus 2 minus 2 which will equal 4. Okay. Now let's talk about compositional functions. Okay. I'm going to go ahead and let you read that text on your own. I'm going to talk about how to combine functions using algebraic operations. It's honestly very straightforward. If you see something with a plus, with f plus g, it is telling you to add the functions separately and combine like terms. The same is true of subtraction. If you see them attached to each other with no symbol, that means we are multiplying, and if there is a fraction, it is telling you to divide. That's all, okay? Let's go ahead and do that on the next page. I want to go ahead and add f plus g of x. That means I'm just going to go ahead and take these guys and combine like terms. That's just going to be 3x plus 0, or 3x. On the next one, everyone always forgets to distribute the subtraction. So we have 2x minus 3 minus x plus 3. I am going to distribute that negative. It is not minus x, it is minus x plus 3. That's going to get us 2x minus 3 minus x minus 3. There is a difference. That will get me x minus 6. In the next one, I'm essentially going to have to FOIL. Okay, so I'll show you what that would look like. So we'd have 2x cubed plus 6x minus 3x minus 9, or 2x cubed plus 3x minus 9. Okay. Whoops, that's definitely not cubed. Sorry. Squared. And then the last one is going to be simply 2x minus 3 over x plus 3. It wants the domain, so x can't equal -3. So your domain is -infinity to -3 and -3 to infinity, not including the -3. Okay. The very last one uses a number instead of x. That means we're going to plug in 2. So we have x plus 3 divided by 2x minus 3. Plugging in the 2 gives us this. So we'll have 5 over 1, which just gives us 5. It really is algebraic operations. It is not something that is completely unheard of for you. Don't overcomplicate it. You are just combining functions and simplifying. You are not necessarily looking to solve for x. I shouldn't see x equals in any of these, okay? Those are function operations. Now let's talk about compositions. Compositions are when we put one function in to another function. We're essentially creating a new input using a function, okay? There's a couple different ways to write them. That's shown right here. There's a little open circle, or you can write it with parentheses. Either one says f of g of x, okay? F of g of x. That's what these are saying. They're saying the same thing. You can write them either way. In order to evaluate this, you're going to solve the inside function using the input value provided, use the result, and put that into the outside function. Okay, so we essentially solve them inside out instead of left to right. For example, find f of g of 1, and then we'll do the rest here in a second. So let's start with f of g of 1. So I'm going to solve g of 1. That's step 1. So that's 3 minus x. So 3 minus 1 is 2. I'm going to use that solution for f of x. That is 2x plus 1. So 2 times 2 plus 1 is 5. Okay, that is going to be my solution. If I want to do g of f of negative 2, I'm going to solve f of negative 2. That's going to be 2 times negative 2 plus 1, which is negative 3. I'm going to put negative 3 into g of x. That's going to be 3 minus minus 3, which is 6. Now in the next two, instead of solving with a number, I'm literally putting the entire function into the other function. So now I'm putting g of x into the f function. So my f function is 2x plus 1. I'm going to replace x with g of x. I can simplify, and I will get 7 minus 2x. My last one, I'm going to put f of x into g of x. So I have 3 minus x. X is going to get replaced with 2x plus 1 and simplify from there. Notice that the order does matter. It will give you a different answer depending on the way that you write it. Okay, let's evaluate using a table. F of g of 3. So start inside out. So g of 3 equals what? That means I'm going to go to 3, and I'm going to look for the solution. That's going to be 2. So now I'm interested in f of 2. When x is 2, f is 8. Okay, that's this guy. Now let's do this one. When x is 3, what is f? Also 3. When g is 3, when x is 3, g is 2. And last but not least, let's solve using a graph. So now I'm interested in g of 1. So this is my g of x equation. So when x is 1, it's a little hard to see, so let me zoom in here. It looks like my y value is 3. Okay, so now I'm going to come over here and say, okay, f of 3 equals what? So now I have to find my y value for f of 3, which will be 4. Okay. That covers it for section 3.4.